Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Okay, in this video I will show you an example, how to solve the system of linear equation by using Gaussian elimination method. Alright, so in our previous video I have explained about the steps, step by step of the Gaussian elimination method, and also the definition of row echelon. So in general, row echelon can be written as, if we were leading one, then the lower row, leading one is further to the right than the leading one in the upper row. So if you have three rows and the leading one is further to right than the leading one in the upper row. So this is the example, solve the system using Gaussian elimination method. But before I solve this example, I want to show you the steps of elementary row operation. Since we have the step of reducing the augmented into row echelon, we have to use the ERO here, right? So I want to show you the steps, for the ERO. So our target here is to find the leading one. If we look here, we have first leading one, then below first leading one is 0 and 3. So this is second leading one, below leading one is 0, and then we have the third leading one. So our first step is to find the first leading one. So to get the first leading one, we can use either two operation in ERO, by interchanging two row or by multiplying a row with a non-zero constant. After we find the first leading one, we eliminate below first leading one to become 0. So this can be done by using the elimination process, EDRO. So we have first leading one and below first leading one is 0. Next step is to find second leading one. So we can use the changing row or by multiplying a row with a non-zero constant, but make sure that first row is locked on the first row. After we get the second leading one, then we eliminate below second leading one to become 0. So we can use the elimination process. And the final step is to find the third leading one. So we can use the multiplication to the row with non-zero constant, right? So after the steps done, we will get the row echelon matrix, and then we can proceed to the second last step, change into system, and then get the solution. Now we look at the example. Right. So our first step is change the system into row echelon row augmented matrix. So the augmented matrix is a matrix with combination A with constant, right? Okay, next first step, okay, refer to the guideline here, find the first leading one. So we have the first leading one here, so we can proceed to the next step to eliminate below first leading one to become 0. So we have two rows here which are not 0, so we have to eliminate. So the row is R2. Okay, then below first leading one is 2, so we put the negative number. So leading one is on the first row, R1, interchange the R2. So what is the operation? So we just copy the element in the second row, then we multiply first row with negative 2. So all element in the first row multiply with negative 2. Okay, negative 2 to negative 4. Negative 2 times negative 4, 8. Negative 2 times negative 4, 8. And then we sum up the value. So 2 plus negative 2, 0, 5 plus negative 4, 1. Negative 9 plus 8, negative 1. Negative 10 plus 8, negative 2. So this is new R2. Okay, just copy the element. Okay, then this is a new R2. Okay, you can copy the third row. Right, next step, eliminate third row. So R3 plus negative 3 R1. So just copy the element on the third row, and then multiply first row with negative 3. So negative 3, negative 3 times 2, negative 6. Negative 3 times negative 4, 12. Negative 3 times negative 4, 12. We sum up the value. So we have negative 8, 15, 23. So this is new R3. Okay, then we just copy the element with the new R3. Right. Okay, we have settled the first reading one, and below first reading one are 0 elements. Okay, next step, third step, to find second leading one. So we have already have the second leading one here. So we can proceed to the next step, that is to eliminate below second leading one to become 0. So the row to eliminate is R3. Then we look at the below leading one here, negative 8. So the number is negative, positive 8. So leading one now in the second row, right? So we write all the element R3. Okay, then 8 times R2, 0 times 8, 0, 1 times 8, 8. Negative 1 times 8, negative 8. Negative 2 times 8, negative 16. Okay, then we sum up. So 15 minus 8 is 7. 23 minus 16 is 7. This is R3. Okay. Okay, then we copy the value. Okay, with new R3. So we have finished to eliminate below second leading one, and then the final step is to find the third leading one. So to find the third leading one, just multiply R3 with 1/7. Alright, so we have done. Okay, we have every row has leading one. Okay, first leading one on the first row, second leading one in the second row, and also third leading one is the third row. Okay, or the leading one is further to the right. Okay, the lower row is right to the leading one in the upper row. Right, so this is the row echelon matrix. Okay, like the definition of row echelon. Okay, so next step is we change back the matrix into system of linear equation. That means we have to convert into system that is in term of the variable. So this is the first row, and this is the coefficient x plus 2y minus 4z equal to -4. So this is first equation. Then second equation is y minus z equal to -2, and third equation z equal to 1. Okay, after we change into the system, we can realize that we have a solution for the variable z. Okay, z is -1. And to find the solution for x and y, we can substitute, okay, into the next equation. Okay, so this is called the back substitution method. Okay, we have the value for z, and then to find the value of y, okay, we use second equation, then we just substitute. Okay, -2, z. We move to the right hand side, we have positive z. So just substitute the value of z, which is equals to 1, so y equal to -1. And x, for the first equation, we have -4 minus 2y plus 4z. Then we just substitute the value of y, which is -1, and z is 1. So we have -4 plus 2 plus 4, so x equal to 2. So we have solution, okay, for x equal to 2, y equals to 1, and z equal to 1. Hopefully you will understand the method of Gaussian elimination method.